Okay, so I would like to try to graph h of 3x if h of x is 2 to the x for 6.3 over 4, which I would do how?
Plug in 3x for the x over 2.
Okay, so you could do this in two ways. One is you could think about this in terms of shifting rules, right? Another is you could fiddle with exponents a little bit. Okay, so my approaches would be this. If I just start with this stuff, right, I'm going to think, what's the 3 doing? Is that one of these, or one of these, or one of those, or something like this?
One of these. No.
That's it.
One of these. Critical switch. Yeah.
So is it affecting the x's or the outputs?
The x's.
Yeah, it's affecting the x's, so it's a horizontal compression because there's no justice in the world at all, right? So this is a horizontal compression. And then you just need to know what 2 to the x looks like, right? Okay, so 2 to the x looks like this because all the positive number to the x's look like this as long as the positive number is bigger than 1. So this is a to the x for a is bigger than, strictly bigger than 1. They all look like this. Right? They're all kind of exponential growth up to some like change in how you count the population, basically. You guys cool with that? So this works for 2 to the x. It also works for, what happens if you horizontally compress this picture? Yeah, it looks basically the same because I didn't label anything, right? So if I wanted to make this 2 to the x, I could label some points. So this is
1, 1, 1, 0.
0, 1. Because if you plug 0 in for the exponent, right, you get a to the 0, which is 1 for anything that's not 0, right? Yeah. You guys do that? And I said a was bigger than 1, so it's definitely not 0. Okay, so now if I want to make this picture 2 to the x, specifically, what other point should I put on here? Yeah, I should put the 1, 2 on here. And so if you plug 1 in, you get 2 out. Hey, I did a pretty good job. Cool. So if I horizontally compress that by a factor of 3, right? What's going to change about where 0, 1 is? Nothing. So that's going to stay where it is. What about this 1, 2 business?
1/3 2.
That's going to be 1/3 2, right? So that's going to get shoved in by a factor of 3. And then make your little whoop-de-hoo to connect this, right? So you got something like this. But that's a horizontal compression, right? But that looks a lot like a vertical stretch to me. You guys see that? So what the hell? So another thing you could have done, oops, if I followed Jeremiah's original suggestion here of plugging 3x in for the x over there, then y of x is 2 to the 3x, right? You guys with that? Okay. What's 2 to the 3x? How about that's 2 to the 3 to the x? Which is 8 to the x? You guys see that? So that's the same picture, right? That's still that blue thing. So that's a little bit why it looks like a vertical stretch, right? Is it actually a vertical stretch? How would I try to figure out if it's actually a vertical stretch? Okay, what would a vertical stretch look like? I mean,
Y's.
algebraically, what would a vertical
Okay, you
stretch
affect your y's after the output.
Yeah, I'd multiply by something after I did the 2 to the x thing, right?
You multiply by something larger than y.
So I think a vertical stretch, right, would look like this. I'd have like some number times 2 to the x.
Right.
You guys see that?
Yeah.
Um,
This is affecting the input, it seems.
yeah, it seems like I'm kind of stuck. Is there an exponent rule that would get me to a number times 2 to the x?
Oh.
You might think that this should be like 2 cubed, right?
Yeah.
But what's the exponent rule that goes with this?
To add the exponents together.
Sorry,
That sounds like me.
it is you. I was trying to see if there was.
So what's the exponent rule that goes with this?
You add the exponents.
Yeah, you'd add the exponents, right? So you'd get 2 to the x plus 3.
Yeah.
Oh, that's a bit weird, right? That's saying that apparently a vertical stretch is actually a shift.
Wait.
Is a left shift.
Oh, right.
You guys see that?
Yeah.
That's kind of weird, right? So depending on the function you're looking at, right, there might be some relationship between like vertical stretches or horizontal compressions and like other shifting rules. That is a thing that happens. In this case, what I have is not quite that, right? Because I don't have x plus 3, I have 3 times x.
Right.
Right? And so the only kind of rule that's available to me is this one. Or I could think about doing that the other way. I could do 2 to the x cubed. Right? But I don't have a shifting rule for what happens when you cube the output of something. You guys see that?
Yeah.
Okay. So we're not looking at a vertical stretch here. We're just looking at a horizontal compression. And that looks like this, which happens to also be the graph of 8 to the x. Cool? That help a little bit?
Yeah.
Yeah. Did I pick up where you were lost? Where were you stuck?
Well, I don't know. I substituted it wrong in the middle, but this is 1.